Hello students and welcome to Lesson 2 of Unit 3. In this lesson we will be studying how to simplify numeric expressions, and this does involve the order of operations which you've previously learned as parentheses, then exponents, then multiplication and division from left to right, and addition and subtraction from left to right. Our essential questions for today are: what is the order of operations? Why do we use it? And how do we use it? You may remember the order of operations as one of these two sayings, either "Please excuse my dear Aunt Sally" or "Purple elephants must dance at school." Notice, either way, my dear and Aunt Sally go together just as much must dance and at school go together, because they stand for multiplication, division from left to right, and addition and subtraction from left to right. The order of operations begins with parentheses. Now, parentheses is more than just the symbol for parentheses, which is this. It also includes all brackets and braces, absolute value symbols, which are two straight lines, square roots, and fraction bars. All of these are types of parentheses. So when you write a P as your first check in your list of things to do in the order of operations, remember, parentheses is more than parentheses. It includes all grouping symbols. The second step in the order of operations is exponents, such as squares or cubes, and you have also learned about integer exponents like -2 or -4, which we know move to the denominator. Those need simplified second in the order of operations. Third in your checklist is multiplication and division from left to right. So if the division is the first thing written in the problem, then division can come before multiplication. Whichever one is read first from left to right occurs first. And last, addition and subtraction from left to right. This is how you are permitted to make yourself a little cheat sheet or a cheat checklist in this class. So why do we need the order of operations? Think about this. Pretend you know nothing about the order of operations. How many different answers can you come up with to one question? Here's one question, for instance. Say you didn't know you had to do the order of operations. So you did 3 plus 8, well that's 11, so we have 5 times 11 minus 4. Well, 5 times 11 is 55 minus 4, so we could get 51. Or if we did something differently, we could do 8 minus 4 is 4. 5 times 3 is 15, plus 4 more, well now it's equal to 19. Or maybe you do 5 times 3 is 15, plus 8 makes 23, minus 4, and you still got 19. That's a different way of getting 19. Or maybe you do 8 minus 4, well that's 4, plus 3 would give you 7. 5 times 7 is 35. Well, if there were no order of operations, look at all the different answers that you could get. One expression could be any value, and if you notice, this expression is only 4 terms long. So the reason they came up with it was, after great discussion long ago, it was agreed upon that the following steps would be taken so that language, nationality, nor teachers could get in the way of math communication. In other words, any one expression would only equal one answer. And the order they agreed upon was, as we've talked about, grouping symbols, exponents, multiplication, division from left to right, and addition, subtraction from left to right. So let's practice simplifying numeric expressions. I'm going to write over here a little checklist that will help us. and we'll answer yes or no questions using this checklist. So, do we have any parentheses? And you would answer yes. We have two sets. Because these two sets are separated by multiplication, we can do both of them at once. 8 minus 2 is 6. We have 6 squared times 8 minus 1, which is 7 squared, divided by 3. Now, do we have any more parentheses? No. So we can check that off. We're done. Do we have any exponents? And the answer is yes. Here we have a square and here we have a square. So because they are separated by multiplication, we can do each of them at the same time. 6 squared is 36, times 7 squared is 49, and divided by 3. So do we have any exponents anymore? No, so we're done with that. Do we have any multiplication or division? And the answer is yes, we have both. So we're going to have to do the multiplication or division from left to right, one at a time. So the first thing that we can do is 36 times 49. And for time's sake in the video, we'll use our calculator. 36 times 49 is 1,764. Afterwards, we will need to divide that by 3. So 1764 divided by 3 is 588. If we had more time, we could do that on the side of our paper to get the same answer. So this numeric expression is equal to the value 588. Notice we did not have to complete every step because once we did our multiplication and division, we got to a constant, we got to the value. There was no addition or subtraction outside of the parentheses for us to complete. Let's try another example. 12 divided by 3 times 8, all to the second power, times 8 minus 2 plus 3. Now, make your checklist, parentheses, exponents, multiplication, division from left to right, addition and subtraction from left to right. Do we have any parentheses? And the answer is yes. This whole expression here is in parentheses. Well, what inside of the parentheses will we have to do first since there's two operations? We have division and multiplication. Multiplication and division has to be done from left to right, so we'll have to do this part first because it's on the left. 12 divided by 3 is 4. Now we still have parentheses because we still have an operation inside. And notice I'm just rewriting the rest of the problem, one step at a time. Now, re-ask yourself the questions. Do we have any parentheses? Yes, here we have the parentheses which say 4 times 8. 4 times 8 is 32. So we have 32 squared times 8 minus 2 plus 3. Now, do we have any more parentheses? This is a little bit of a trick. Yes, we have parentheses, but there are no operations inside to simplify. So this parenthesis is only saying that this base is to the second power. So we do not have any more parentheses. Do we have any exponents? Yes, we have 32 squared, which we know means 32 times 32, which is 1,024. So I rewrite 1,024, which is 32 squared, and rewrite the rest of the expression. Now, do we have any more exponents? No, but we do have multiplication in our problem. So when we go to the next one, it says multiplication division from left to right. We only have one set of a multiplication, so that's what we're going to do first. 1,024 times 8, which is 8,192. So we have 8,192 minus 2 plus 3. Do we have any more multiplication or division? No. Do we have any addition or subtraction? Yes, so we must complete that from left to right. The subtraction comes first from left to right, so we'll have to do it first. 8,192 minus 2 is 8,190. And then we have plus 3 at the end. So last step, add 3, we get 8,193 as our final value of the expression. Now, we talked about how parentheses means more than just parentheses. Parentheses also includes other grouping symbols like fraction bars, absolute value symbols, and square roots. So let's do some examples with these types of grouping symbols. Let's start with a fraction bar. This fraction bar cannot be simplified until both the numerator and denominator have only one value. I like to simplify each of them separately and then do our fraction bar reduction or division. So if you look at the numerator, we have subtraction and we have an exponent. Which one has to be completed first, subtraction or an exponent? Exponents must be completed first. So we have a square and the base number is 2. So 2 squared is 4. So we have negative 22 minus 4 over 5 minus 3. Now continue working on the numerator. The numerator only has one operation remaining, and that is subtraction. So negative 22 minus 4. If I owe 22 and I owe 4 more, then I owe 26 over, and I'm just going to write 5 minus 3. Now, if you look, we have simplified the numerator to one value. We can do the same to the denominator since it only has one operation. 5 minus 3 is 2. So we have negative 26 fraction bar 2. Now remember what a fraction bar means. A fraction bar is division. So we know that a negative divided by a positive is a negative, and 26 divided by 2 is 13. And if you didn't know that, you could make a divide box and see that. So the value of this expression is negative 13. Let's do an example with absolute value symbols. Now remember, absolute value is how far a number is from 0. It's a distance operation. It will always equal a positive number because even if you walk backwards, it's still a distance. It's still positive. Now, since our absolute value symbols here are grouping symbols, we have to do what's inside first. There are two operations, subtraction and an exponent. Which one has to be completed first, subtraction or an exponent? Subtraction first, exponent first. So 5 squared is 25. So we have the absolute value of 10 minus 25 divided by 5. Now we still have our grouping symbol, our absolute value symbol, so we have to do what's inside next, and that is subtraction. If you have 10 and you take away 25, then you have negative 15, still in absolute value symbols, divided by 5. Now, do we still have parentheses? Yes, but we're down to one number inside, so we can perform the absolute value now. How far away from 0 is negative 15? And the answer is it's 15 digits away. Last step, 15 divided by 5 is 3. So this expression has a value of 3. Let's do one more example before we go to the next video. If you see a square root symbol, it is part of a grouping symbol in the parentheses. So we have to do what's inside first. 50 minus 1 is 49. So we have 3 times the square root of 49. Well, we know that the 49 is a perfect square root and that equals 7. So we have 3 times 7, which is 21. So this expression has a value of 21. See you in video 2.